Okay folks, a few more area formulas to sink your teeth into. Let's go! So the first one we're going to look at is an alternate way of finding the area of a triangle, and that's using this half AB sine theta. Now you have to have a little look at your calculator, find the sine button. It's somewhere in the middle of those extra keys above the numbers. It looks like it says sim, but I promise it's pronounced sine. And it would be good to do a little bit of a check here that sine 30 equals 0.5. So if you type in sin 30, do you get 0.5? If you don't, then your calculator's set up in the wrong sort of mode and you'll have to go and fix it. Now, let's actually have a look at using this then. So if we want to find the area of the triangle on the left hand side, we have to pick the sides that are relevant. So you'll notice that we want to pick two sides, A and B, and the angle that is between them. That's our theta. So our angle is 68 on this first triangle, and the two sides between it are the 13 and the 12. So we actually don't need the 14 at all. Bear that in mind. So area is going to be a half times A times B times sine 68, which will give you a total of 72.3 centimeters squared. See if you can apply that to the second triangle. I'll show the answer in 3, 2, 1. Okay, there we go. So the key is obviously to realize that it's the 6.6 we don't want, because the 42 is in between the 9 and the 9.5, and that gives us an area of 28.6. Cool. So let's have a look at a few more. So one thing we can obviously do with this is we can try and rearrange it to find missing sides. So let's use this first example. We've got an area of 24. So let's set that up and say we've got 24 is equal to, and it's a half AB sine C. So we've got our A and our B are 6 and Y. It doesn't really matter which way around we say it. So a half times 6 times Y, and then theta is 110. Cool. How could we simplify that down? Well, I'd probably actually figure out a half of 6. That's just 3. Then we've got Y, and then we've got sine 110. And then if we want to get just Y on its own, we're going to need to take that 24 and divide it by 3 lots of sine 110. So that will give us there a final side length of 8.51 centimeters. Feels about right. Have a go at the second one. Unpause when you're ready. I'm going to show the answer in 3, 2, and there we go. 7.95 centimeters. Cool. So that's one formula. What can we use it for? So we can use this formula for the area of a triangle to work out the area of a segment. Now remember, if we have a circle, a segment is one side of a chord. So it could be obviously the right hand side there, that would be a minor segment, or it could be the left hand side, that would be a major segment because it's more than half. Now if we want to find the area of that segment, we should note that it is the entire area of the sector, that's the red and the green bits put together, take away the area of the triangle. So if we take away the green, we'll obviously just be left with the red part of that circle, and that will be our segment area. Now we know formula for sector area, and we know a formula for triangle area, so we can put them together and we can get this horrible looking thing. Now I would discourage you from trying to learn this as a separate area of a segment formula. This is just a combination of two things that you should learn. You should learn how to find the area of a sector, you should learn how to find the area of a triangle. So one more point here, we've got this r squared here. Where did that come from? So the formula for triangle we just looked at was a half AB sine theta. But what is A and B? Well, A and B are R and R because they are the ones either side of the angle in question. So we could replace that A and B with R and R, and then R times R obviously gives us R squared, which means we're going to do a half R squared sine theta for the area of that triangle. So let's look at a little tiny triangle, only 0.96 radius, and let's find the area of the little green shaded segment. So I'm going to do this in 3 stages. I'll find the area of the sector, I will find the area of the triangle, and then I will do a subtraction to find the area of the segment. Pen's not appearing there. Okay, right. So let's do the sector first. The sector is theta over 360 times pi r squared. So 47.1 over 360 times pi times 0.96 squared. The triangle is a half r squared sine theta as discussed. So that's going to be a half times 0.96 squared times sine 47.1. And the segment is going to be the sector take away the triangle. So let's plug those numbers into a calculator and see what they give us. So for the sector we should get 0.3788 and the triangle 0.3376, and then to find the segment we're going to do a subtraction of those two things. So we're going to take our sector, we're going to subtract our triangle, and we're going to get the area of that segment is 0.0412 centimeters squared. Very, very small, but it is a small circle and it's a small part of a small circle. And we can't help how we're made. So, two more questions that I'd like you to have a go at. I'm just going to fill in here that this angle is 140 degrees. You would actually need to use something called the cosine rule to find that, which we won't look at for quite a while, till chapter 19. So if you're just doing this question from blank, just use the fact that's 140. Okay. If you want to pause the video now and have a go at those two, unpause when you're ready, and I'll show the answers in 3, 2, 1. So for the first one, you should have got a sector of 20.25, a triangle of 4.59, and a segment therefore of 15.66. And as for the second one, you'll get yourself to a final answer of 57.62. Okay, so let's try and put this all together. So we should now have three formulas that we know. There's a formula for arc length, for sector area, and both of those are just theta out of 360 times the circumference and circle area. We've also got this new formula for the area of a triangle, half AB sine theta. By putting this stuff together, we can obviously come up with a formula for segment area, though as I said, don't try and remember that. Try and remember the triangle area and the sector area and work it out when you need to. Now this is from a non-calculator paper, so put those calculators away, and we want to find the perimeter of this shape in terms of pi. Now I would like you to pause the video and have a go at this, see what you come up with, and I will show you what I think in 3, 2, 1. Okay, so the perimeter of this shape consists of three distinct things. Firstly, we've got those two 3 centimeter short sides, so that'll give us a total of 6. Secondly, you have the longer 6 centimeter sides, so I can go 6 plus 6 is equal to 12. So we're up to 18 so far. And lastly, you've got the two arc lengths, so we want to use the formula for arc length, theta over 360 times pi d. So let's do one of those. We would have 150 over 360, because that's the angle, times pi, and then times the diameter. So remember, the diameter is going to be double the radius. Radius of these circles looks to be 6, so we're going to have 12 as our diameter. Non-calculator, so resist the urge to type this in. We're going to simplify this fraction on the left, so we can obviously cancel out a 0, and then we've got ourselves 15 out of 36. But we can go further than that. We could divide by 3 at that stage, couldn't we? We can say we've got 5/12 times pi times 12, and that's really good, because 5/12 of 12 is 5, so that will give us 5 pi. And that's just one of those lines, so we need to add the other 5 pi to it, and we've got total cells of 10 pi. So what's the total perimeter of this shape? Perimeter is 10 pi, add 12, add 6, add 18. Units will be centimeters. It's not as bad as it looks, that one, particularly on a non-calculator. Okay, let's look at one more question and bring in some segments and triangles and things. Okay, so on this one, we're told the area of this logo is 510 centimeters squared, and we want to find the radius of the sector BCE. So we want to find the value of this R here. We're told that ABE and DCE are congruent triangles. Now congruent means the same, and all that tells us is that if we know the area of one triangle, we know the area of the other, and it clarifies BC is a sector of circle, center E. Okay, cool. So how are we going to do this? Well, we know that the shape boils down to three things. It's got two triangles and a circle. So the first thing we should do is we should try and find the area of the triangle. So we can do that obviously using a half AB sine theta. A and B are 26 and 15, and sine theta is 38. Looks like that makes sense to me. So a half times 15 times 26, and then times sine 38, which gives us 120.05, but there are two triangles, so we need to times that by 2 and get that both triangles put together give us a total of 240.1 centimeters squared. So what can we do with that? Well, the area of the logo is 510, so what we could do is find the area of the sector by subtracting that from 510. So if we do 510, take away 240.1, we're going to get ourselves to 269.9 centimeters squared left over, and that is the area of our sector. Well, that's going to be equal to the formula for the area of a sector, theta over 360 times pi r squared. So we're going to have 108 over 360 times pi, and then the radius we don't know, so just say times r squared. And then we'll do what we did last time. We'll multiply up by 360. Multiply both sides with that. And then we'll end up with a ludicrously large 97,161.1 on the left-hand side and 108 pi r squared on the right-hand side. What do we do now? Well, we want to divide by 108 pi. Which is going to give us a slightly more manageable r squared is equal to 286, and then we don't want r squared, we want the radius, so we can finally say that the radius is equal to the square root of 286, or 286.4 as I've actually got, and that would tell us a radius finally of 16.9 centimeters. So there you go. Couple of top tier GCSE questions, arcs and sectors, lovely stuff.